Hello and welcome to SDN Tech Forum. It is my great pleasure to introduce you to my new book, IoT with LoRaWAN. It is available to order today at Amazon.in. Very soon it will be available worldwide. As you know, I'm an IoT practitioner and I have been talking about LoRaWAN for many years. So when I decided to write my book, it was quite implicit for me to write about LoRaWAN because I'm so impressed with the technology. However, it took me some time to come up with the agenda because I wanted to write a book that can be used by everyone. That's why this book essentially covers the fundamental, the ecosystem, and then I'm also showing you a proof of concept, a working prototype solution which demonstrate the solution end to end. And essentially, that's what I'm going to show you in this video. The same prototype what I'm showing in the book, I'm going to show that experiment live in this video. However, if you are a visual person and you want to learn quickly about LoRaWAN, you can go to my channel, YouTube, SDN Tech Forum channel, and search LoRaWAN. You'll see LoRaWAN explained. This is a short 6 to 7 minute video where I'm explaining everything related to LoRaWAN. So go ahead and watch this. We will be taking cues from this video while I walk you through the experiment. So this is a LoRaWAN architecture. And before we delve into LoRaWAN architecture, a very quick summary of LoRaWAN. What is LoRaWAN? LoRaWAN is a communication technology. It's a sub-gigahertz technology. That means 915 gigahertz here in US, 868 in EU, and so on. So it's sub-gigahertz frequency. That means carries less amount of data, but it travels longer distance. So that's why it is very well suited for an IoT technology because IoT is least amount of data, but it covers a vast field. So that's why LoRaWAN is pretty suited architecture for that. How this architecture is built, this is the complete architecture. End devices, gateway, network server, and application server. End devices are essentially your sensors that senses data and send this data to gateway. And end device to gateway communication essentially happen over LoRaWAN signals. Gateway serving a dual functionality. So at one side, it is listening to LoRa signals and acting as a receiver. And on the other side, it acts as a transmitter because it sends those data coming from end devices to upstream network server and application server over IP, say Wi-Fi or wired connection. So that's why it serves as a dual function. Because if you sense the data, you want to process that data, and the processing that data may happen anywhere over the internet. So you need that IP connectivity, of course. So this is what our ecosystem looks like. And additionally, I'm going to walk you through how we can merge our LoRa application domain to other domain using a bridging protocol called MQTT. And I have done a couple of video on MQTT as well. So you can search MQTT on my channel and watch that video. With that, let me go ahead and introduce all the component one by one. So first, we are going to go to our sensors. For sensors, I'm using two different type of sensors for two different segment of people. One who are programmers, they can handle the Arduino programming. So we have the sensor MKR-WAN 1310. This is a board with LoRa chip on it, so it can send LoRa signals. However, sending just one or two LoRa packet may not be really appealing close to real life scenario. So I decided to bring in a shield, MKR environmental shield, which has a lot of sensors on it, pressure sensor, temperature sensor. So it senses the environmental data, and MKR WAN 1310 in turn relays that data to the gateway. But the caveat is you need to program this. For easy starters, there are plenty of commercial off the shelf solutions are available, products are available, and I'm using one of the product here, LDS02 LoRaWAN door sensor. So it's essentially a door sensor. If you open the door, it sends a signal. If you close the door, it sends a signal. The benefit is you don't have to program this because vendor owns the responsibility of giving you the payload, decoder, and all those things. You really don't have to program this. Just put a battery and it will start working. So that is our end device. Moving on to the next component, that will be gateway. And for gateway, we are using inexpensive gateway, Dragino LPS8 indoor LoRaWAN gateway, tuned to 91500 megahertz frequency, sub gigahertz frequency, as I mentioned, right? It serves dual function. It is listening on LoRa frequency. As you can see, it has a Wi-Fi and RJ45 connection, and that's for the IP connectivity. So you can simply connect it to your router, or you can connect the Wi-Fi to your router SSID, and in that turn, if gateway is registered to upstream network server, it will relay all the sensing information to network server. So that is essentially our gateway. So for network functions, we are going to use the ThinkStack Cloud Discovery account. It's a free account, and this is where you are going to register your gateway. You can register your onboard your application or end devices, and it will receive all the sensing data from the gateway, from the registered gateway. Although ThinkStack allow you to do application function as well, that means it can act as an application server. However, here I'm splitting the network functionality and application functionality to two different portal just based on my experience. That is, application server is sitting on a different portal. And what is that? That is going to be DataCake. DataCake also give you a free tier account, so you can onboard a few of your end devices here, and it is quite user friendly. Dashboarding is pretty easy. So it's not that ThinkStack is not capable or DataCake is not capable of doing both the function, network and application function, but I'm just showing you best of both world, and that's why we have this thing splitted. So our programmable sensor, commercial sensor as endpoint, then we have a gateway, then we have a ThinkStack as our network server, and we have DataCake as our application server. Additionally, if you remember, I told you that we are going to stretch this to other IoT application as well. And how you can do that? You can bring MQTT, which is a standard protocol. You can bring use MQTT to relay this whatever data you are sensing to the other domain, whether it's AWS IoT or your homegrown IoT. You can relay that using a very popular standard protocol. And what is that? That is Node-RED. Node-RED can serve as MQTT server, and it can receive all the data from your application server based on MQTT integration. And from there on, you can do multiple type of integrations. So now, as you have seen all the component, let's go back and start digging into each of the component so that you can understand the flow end to end. Now, so you are familiar with the ecosystem and the component. Let me show you the network server. A network server from ThinkStack is very capable and is very useful. So if you're starting, I would recommend you go get a ThinkStack Cloud Discovery account. It's a free account. It allow you to onboard 5 sensors and 1 or 2 gateway, so without any charges. So go ahead and get an account. So this is my account. Here you can see once you log in, you have home, application, and gateway. So you created an account. ThinkStack has like multiple accounts. It's a multi-tenancy, right? So there are many gateways in the world. They are sending this data to ThinkStack. How ThinkStack will know which gateway or which end devices belongs to who? So for that, we need to register. We need to tell ThinkStack that I am the owner, or this is my gateway. And how you are going to do that? You're going to go to ThinkStack gateway and say register gateway, and you put the gateway EY, and that is a hard coded. Think of it's like a MAC address, hard coded address for your gateway. And you can also do authentication as well. So once you register your gateway, any information broadcast coming from that gateway will be accepted and sent to your organization. As you can see, my gateway is registered and it says status is connected. And if I click on it, it expands. It shows me all the parameter, the frequency plan, status, if authentication is enabled or no, and tons of things. If you read the book, you will get to know about this parameter. It is sending information via UDP. And this is my status. This is the uptime and latencies. You can also visualize the live data. You can create API keys for authentication and few other settings. So that's the first step. Once you register a gateway, now what is gateway used for? Gateway is essentially sending us the sensing information, but it is sending all the information in bulk. So we need to identify individual sensor. And for that, what you're going to do, we are going to go ahead and go to application and create an application. Don't confuse it with like any web or DB or any other SaaS application. Application in Things Network is essentially a bucket or logical bucket for all your end devices. So you create one application, and once you create the application, under that you can assign individual end devices. So let's go ahead and create an add application. It is simply a logical bucket, nothing else. For analogy, if you have home and office, you want to create 2 application, home and office, and then put individual sensors in each of those applications. So as you can see, I already have one application created. Let's double click on that, and now you can see on the left hand side, this palette, we have end devices. So here you can go and add new gateway. You can add register end devices in this application. So I'm going to go ahead and add more end devices. However, in my application, you can see I have 3 end devices. door sensor, as I mentioned, commercially available sensor, and then we have MKR, the programmable sensor. Okay, it also give you just like a gateway snapshot, how many messages were stored and all those data. We can click on individual end devices or sensors and get more detail about it. Here you can see this is our device overview. Again, just like gateway, we have all this end devices related information. These are the like technical parameters. If you read the book, you will get to know about this interesting thing. At the same time, you can see latest decoded payload. Sensors are sensing data, sending that data to gateway as ASCII payload. It's not saying that I'm sending you a battery voltage of 3 volt or I'm sending you a temperature of 25 degrees centigrade. It's just send the data coded in ASCII. However, that coding doesn't make sense to a human. So what we need to do, we need to decode that data. And that's why here you can see we have the decoded payload. And now if you see the decoded payload, it makes sense. The battery voltage is 3 volt and dose status is 0. Depend on how you code, 0 may be closed, 0 may be open. So battery door status is 0. I'm going to do a few open and close in real time, and you will see these things will change. You can see now it's changed to 1. So ThinkStack is really powerful. It can act as a network server, and at the same time, it can act as an application server also. That's why you can decode your payload and visualize it here. Although this 0 and 1 is not really great visualization, and that's the reason we will move to data cake for application visualization. All right. So how this payload is being decoded? Let me show you payload formatter. And here you can see we have this program that actually takes that ASCII data and convert it to human readable payload. If you are buying a off the shelf sensor, then you don't have to worry about these payloads because these payload formatters are available from vendor's website. So we have the payload decoder available from Dragino, just from the product manual itself. You can just simply copy and paste it here and see that data. You can also do live data visualization and all those things. However, the challenge is if you are bringing your own programmable sensor, then you need to worry about the payload decoder. So this is my programmable sensor sending data, getting data, and all those things. Here you can see live data, and here we have forwarded uplink and downlink data. I showed you Things Network working as a network server, a little bit of application server also. Now let's move on to our application server, which is DataCake. And DataCake is a IoT company that allow you to create a free account, and it gives you like a two sensor that you can visualize. And for that, what you can do once you create your account, you can simply go and create a fleet of devices. And here you can see I have two devices onboarded, door sensor and MKR. We can also bring gateway functionality because DataCake has all the functionality of ThinkStack as well. However, we are not bringing our gateway here because gateway is only sending information to ThinkClouds. That's why you won't see anything here for the gateway. But there is a so much potential here. So let me go back to our all devices and expand this device, the door sensor, and here you can see a nice dashboard in real time. So it has a lot of custom and vendor specific dashboard already available. All right, let me open the door in real time. Yes, and now close the door. And I'm not editing. This thing is less than 5 second. The status is getting updated. All right. So how this magic is happening here? Once you come to your data cake, what you have to do, you have to go ahead and say add device, and then you can choose what kind of device you want to add. Like I want to add Dragino or whatever your vendor is, even the generic API, right? So I have added my device here, and you have to go to configuration, and within configuration, go to product and hardware, and here you can see we have to create this network server because think about it. We are not getting data directly from gateway because gateway is not registered. How we are getting data? We are getting data from ThinkStack network server because ThinkStack network server already have the gateway and end devices information. So we need to put an integration between DataCake and Things Network, and that's what we are doing here. Show setup integration. Here you can see this is the integration setting you need to do between network server and data cake. So it's a both side. You need to configure things both side, right? So here I'm choosing my network server, ThinkStack version 3, and what is my uplink URL and all those things, API key, all those things you need to show here, and it will actively try to reach out to Things Network. Let me go back to Things Network real quick and show you other integrations. API key. Here you can see we have this data kick downlink integration. So we are doing a API key based integration between Things Network and data kick. So let's go back to data kick platform. Once you have this integration, then you will start receiving that data. So once you have the integration in place, you need to apply payload decoder, just like what you have seen in network server. Use that payload decoder, and the payload decoder will decode the ASCII information and map it to our dashboard widgets. So this is the vendor specific dashboard available out of the box. So you don't have to do anything. It can simply decode and show it here. However, for programmable sensors, you need to do a little bit of lifting. That means these widgets are not created automatically. So you can pick up a generic board and then change the widget to whatever parameter you're getting. Right now, you can see we have temperature, humidity, parameter. However, the illuminance is not receiving anything. And this is by design because I wanted to do this here in this live in this video. So you simply, we go to configuration just like before, and we are going to apply the payload decoder. We are already receiving data via ThinkStack integration. This is the payload decoder. I wrote it for my MKR WAN 32. This information is also available in my GitHub, and I'll walk you through the GitHub in a moment. So once you have the right payload decoder, it can decode the data and start mapping it to the fields of your generic dashboard. So let's go to the fields, and here you can see my temperature is getting identified as temperature 0. So that within the template, the generic template, what I picked up, it has the inbuilt identifier, and temperature 0 is for temperature. Humidity is humidity 1, and barometer is barometer 2. However, illuminance you can see is 0. But how we are receiving that? We are receiving it at illuminance 3. And this is kind of like intelligent enough to give you a suggestion. If the mapping is not accurate, it can actually understand that and tell you that, hey, you know what, you are mapping it to Illuminous 0, but the generic template advise you to use that. So let's go ahead and create this field, right? Because let me go back quickly. You can see we are getting data for temperature, humidity, and barometer, but we are not getting anything here because it's not mapped to the right field. And let's do that. Just going to field right now, illuminance is mapped to underscore 0. I'm getting a suggestion that instead map it to underscore 3. Let's go ahead and say create a field. All right. The field has been added successfully. Let's go to our dashboard. And what I can do, I can actually put this torch on the sensor, and hopefully in next iteration, because this program is actually sending this sensing information every 10 minutes. So hopefully within 10 minutes, we will see illuminance information getting changed and changed to some positive values. While we are waiting for this, we are going to proceed to Node-RED. And here you can see we have a Node-RED flow with MQTT as server. And then we are simply parsing that data or debugging that data. So let me open up the MQTT. Here you can see this is my server. And what is my server? TTN ThinkStack Network is my server. So let me explain the flow. TTN is sending the sensing information via MQTT, acting as an MQTT server. And here I'm working as an MQTT client and subscribing to a single topic, and the topic is hash. That means I'm subscribed to all all the sensor information. And then I can simply go ahead and parse that function or debug that. So here you can see we are getting data and applying the parsing function so that we can see door status is closed or open. So that's how you can actually relay data using MQTT. All right, it's been some time. Let's go back to data cake. Hopefully the brightness information should show here. As you can see, the lux value is still 0. Then let me do one thing. Let me just quickly show you the Arduino program in real time. So here you can see this is our MKR WAN 1310, and I'm running this program from Arduino IDE. And you can see the last sensor reading. We have temperature, humidity, pressure, and brightness information here. However, we don't see anything coming, and this program is running like sensing data and sending it to LoRa gateway every 10 minutes. However, you can see we have the lux info here. So why it is not showing up here. Let me toggle this button so that we can have a real time. And this is a dashboard actually prepared by someone. So all these widgets are mapped behind the scene to MKR WAN 32 parameters. As you know, temperature was mapped to temperature 1, humidity 2, and so on. So we have mapped this, but let me double click here and see what is parameter behind this. So what we can do, we can simply click on edit button here, go to data field. Here you can see we have the field is illuminance and it is mapped to illuminance. However, we are sending data to this parameter, illuminance 3, because that's how I wrote my program. So basically the mapping was different. So let me go ahead and map it here. Although we have done this in payload formatter, but it is not mapped to the widget. So I hope that's the thing that was missing. Let me go ahead and save this 9 minutes ago. So in a minute or two, we should actually see some value popping up here. All right. So now you can see illuminance is 4.52. And here you go. We have the new value 35 seconds ago. And this is an integer. That's why it is only showing us the decimal value. Let me go ahead and change it to real time. I'll show you what's going on. Here you can see we have the title and then data is mapped to illuminance 3. And we are receiving this value on our dashboard. So I'm going to go ahead and say save and get rid of this widget. And then you can see we have temperature, humidity, barometer, and illuminance. So this is how we can see the real-time data on DataCake dashboard. With that, I have shown you the end-to-end ecosystem and how it is working. If you are interested in reproducing this proof of concept, you can go to my GitHub repo, LoRa, and then you'll find all the programs, MKR 1310, Environmental Shield Program, the payload decoder, and for LDS, it's available from the vendor website itself. Let me show you that. So if you go to Dragino and you'll select the Dragino end node based on what is your product type look like, all this product or payload decoders are available here on their vendor's website. With that, we are at the end of the video. Thank you so much for watching, and I hope you enjoy reading my book and give me the feedback. And I'll see you in the next video. Thank you very much.